Let's assume we don't reject the null hypothesis. Let's revisit the same problem with different numbers. Let's assume, as number 2 says here, and this is of course lifted right from your book, the sample data are not in the critical region. In this case, the sample mean is reasonably close to the population mean, and because the data do not provide strong evidence that the null is wrong, our conclusion is to fail to reject the null hypothesis, which is also known as accepting the null. That's a fine semantic distinction, but increasingly we insist on using the language fail to reject the null. This conclusion means that the treatment does not appear to have had an effect. For example, let's check it out. Here's the wordage below, or the verbiage, I guess I should say. For the research study examining the effect of a red shirt, suppose our sample produced a mean tip percentage of 16.1%. As before, the standard error was the same, 0.4, and the null hypothesis says that it should have been at 15.8, right? Everything's the same, except our mean wasn't as impressive. It was 16.1 instead of 16.7. Look what happens. My gosh, in this case, our outcome, the z-score, is only 0.75 in that case. And what are the implications? Well, that z-score is not in the critical region. Therefore, we would fail to reject the null and conclude the red shirt does not appear to have an effect on male tipping behavior. And indeed, here's a graphic illustration of that. So what you're looking at there in black, again, is the distribution of sample means, assuming that the null hypothesis is true. What's that in red? The two critical values of z of plus and minus 1.96. And where do we get that? Well, from before, just as we said, we look up 1.96 in the tables, and that leaves 0.05 or 0.025, I should say, in each tail, 0.0250, strictly speaking. And you can see that that red number, wherein we're looking at, the z obtained of 0.75 doesn't even get close. It falls in the region where we're going to accept the null hypothesis. So what I have here graphically is the same, and I'm going to go way the heck back here, is this sort of example. The middle 95%, if the null hypothesis is true. It doesn't fall out on these wings. Where did the 1.96 come from? Right here from the tables. I'm looking at the value that puts 2.5% in each tail. Now, again, I should say this. This takes a little concentration and a little presence of mind. You have to be able to convert decimals, or I should say percentages to decimals, but not only that, 4-digit decimals. So what's 5% as a decimal going to 4 digits? 0500. What's that divided by 2? 0250. And again, you don't have to know that in your head. Just use a calculator. It's fine. No, I think calculators are underrated. Wish I had them back in old-timey days. But in this case, yeah, we missed it. My gosh, this is the same graphical representation, but we didn't come close to rejecting the null hypothesis. So in that case, we just missed it. It wasn't quite a strong effect. My gosh, 16.1, by the way, think about this. 16.1 versus 15.8, that's only a difference of 0.3 percentage points, which it really isn't a particularly strong effect. So in summary, a hypothesis test always leads to one of two decisions, and that's it. And it's really barely qualifies as a decision. It's more than just looking at the number on the scale. Just like the luggage at the airport, if it's 50 plus, the passenger owes money. If it's 49.8, the passenger doesn't owe any more money. That's what airport employees have to just tell the passenger. So, number one, the sample data provides sufficient evidence to reject the null hypothesis and conclude that the treatment has an effect, or they do not provide enough evidence to reject the null hypothesis. In that case, you fail to reject and conclude that the treatment does not have an effect. Now, I've mentioned this in passing. Number one here, could it fall in that critical region by chance and have nothing to do with the independent variable? Yes. And in that case, that'd be a type 1 error. Conversely, and we'll talk of this later, could there genuinely be an effect, say, for wearing a red shirt, and we just happen to miss it? Could that happen? Yes. Could we have just missed a true outcome? Absolutely. And that would be a quote-unquote type 2 error. So as we'll speak of later, if you've rejected the null hypothesis, the only error that you could have made is type 1. If you fail to reject the null hypothesis, the only error that you could have made is type 2.